Hello everyone, in this tutorial we will continue exploring the tool. We're going to learn how to create animated assets and how to edit or create 3D skins. Let's start with something basic and create a simple animated object. First, add Susan the monkey to the scene. Move it up a little, click Ctrl A, and apply transformations. Create a new armature. Go to the viewport display and toggle the in front checkbox. Let's rename the first bone. Usually the first bone is going to be used by the game itself for various purposes, and we should not attach any vertices to it. Select the root bone and switch to the edit mode. Click Ctrl A to add a new bone. Select the new bone first and the root bone second. Press Ctrl P to parent the bones. Switch back to the object mode and add the armature modifier to the monkey. Click on the object field and select our armature. Select the armature first and the monkey second and switch to the weight paint mode. While holding the Ctrl key, click on the bone you want to assign weights to. Before we start painting, we need to toggle the Auto Normalize Weights option. It's very important to make sure that weights are normalized, otherwise you might get some unexpected results. We painted the front side of the monkey, but let's pretend that we forgot to paint its back. This can lead to some serious issues, and we need to make sure that such thing never happens. To detect these problematic vertices, we are going to use a script. Switch to the Python console. Copy and paste the script that I provided. Problematic vertices are going to be put in the problem vertices group. Switch to the edit mode. Click on empty space and then click the select button. Now you can clearly see what vertices might cause issues. Delete this new vertex group and paint the rest of vertices. By painting our monkey like this, we attach vertices to the bone we selected before. I'm going to change my brush settings to make it paint through the mesh. Let's run the script again. Now as you can see, there are no problematic vertices. We can delete this vertex group. Since we are going to export our asset in the FBX format, we need to rotate the skeleton like this. Now let's animate our monkey. Switch to the timeline pane. Set frame start to 0 and frame rate to 30 frames per second. Switch to the pose mode. Select all bones and click I to add new keyframes. Let's repeat this step a couple of times. Great! Now we're going to export our asset. Before exporting, I'd recommend that you switch the display mode to Blender file. Make sure that you don't add any extra armatures or animations here. By the way, it's okay for a skeleton to add multiple root bones. Toggle the Apply Transform option. And then toggle the Add Leaf Bones option. Finally, run the import command. Just like the last time, I'm going to replace a crate with a monkey. Also, make sure to download the latest version of the tool. Excellent! Now let's try something more interesting. We're going to modify a 3D skin. First, I'm going to export Naruto's default asset, more specifically, the one with the Raisin Shuriken Ultimate Jutsu. Before importing the asset, you need to set the frame rate to 30 frames per second, otherwise Blender will slightly modify the keyframes. Also, set frame start to 0 and frame end to some large number. Don't forget to set bone direction to Blender. When we exported our asset, a JSON configuration file was generated. This config file will help us to preserve some original information about the asset. More specifically, to what submodel groups various meshes belong. These groups are used to animate when some meshes appear and disappear. The game mainly uses this approach to imitate hand animation. Let's make some changes to the model. I'm going to replace Naruto's head with a monkey's head. Assign the new vertices to the head bone. Before exporting the asset, we need to do one more thing. When we imported the GLB asset, Blender used diffuse BSDF shaders for materials. The issue is that Blender doesn't know how to export them back. So we need to convert these shaders to principal BSDF shaders. We're going to use another script for that. Switch to the scripting tab, paste here the script that I provided and run it. Done. Now we can export the asset. Since we did not modify any animations of the skeleton, we might even exclude animations from exporting. Now run the import command. I'm going to replace Boruto from my mob with Naruto. Pay attention to the newbie argument. With it we specified the path to a base asset. The base asset is going to be used to copy some files from the original asset. For instance, if we don't export animations, they are going to get copied from the base asset. Perfect. Now I would like to talk about some extra things. Let's take a look at Boruto's asset. When replacing animations, you need to pay attention to some things. First of all, you need to make sure that all of them are replaced. Also, they need to go in a specific order. Use a prefix for names. When naming bones, follow a bone naming convention. This will allow the game to know to what bones attach different effects and particles, what bones to move in procedurally generated animations. Now let's learn how to give our asset an anime-styled cel-shaded look. We'll start with creating a black outline. A black outline is basically just a copy of the main mesh but scaled along normals. To make it surround the model instead of covering it, we need to invert normals and enable backface culling. We could do this right in Blender. You'll probably notice that Naruto's asset had an outline. However, we are going to achieve the same effect by editing the JSON configuration file. To create a black outline, duplicate the mesh by pressing Ctrl-D and then pressing the Escape key. Make the new object a single user of materials and object data. Rename the duplicated object. Delete its materials, UV data, and vertex color data. Go to the Edit mode. Select all vertices. Click Alt-S to scale the mesh along normals. Make sure that thickness is turned off. I'd also recommend that you optimize this mesh by deleting some faces that are not going to be visible by the viewer or are not going to be noticeable if you delete them. In the JSON configuration file, we need to set the swap triangle winding order option to true. This is basically like inverting the normals. Disable vertex colors, normals, and UVs. Also, set the VFX group to 1. Now let's learn how to create an anime-styled shadow. This is quite easy. Once again, we need to copy the main mesh, but this time we just need to change its texture. We can delete vertex colors and UVs. We will not need UVs since we are going to change the way a texture is projected onto the mesh. Now we need to edit the JSON configuration file. Enable these two options. Disable vertex colors, indices, and UVs. Now let's export our asset. I set facial bones as non-deforming. In the export settings, we can make so that only deforming bones are exported. Finally, run the import command and behold what you have created. Keep in mind that these methods of creating a cel-shaded look are heavy on performance, so use them sparingly. To imitate cel shading, you could also bake lighting into textures. Looks good. That's all for today. I hope you have learned something new. See you in the next video.